So for lesson 88, we're looking at proportions, or proportional relationships versus non-proportional. We've actually talked about this topic already, but lesson 88 is kind of a refresher, or kind of a review of what we've already talked about. If we say that something is proportional and it's in the relationship, we're also saying that it's can be a direct variation. And we had a couple of things that we were looking for. Number one was we wanted to determine whether or not it went through the origin, which in terms of the chart, that meant did we have 0, 0? And then also what we were looking for was did it form a line, which meant did we have a constant rate of change. So for this lesson, we're just going to take a few minutes to look at a couple of different scenarios and just kind of talk our way through whether or not it is a proportion. So for example number one, they want us to state whether each graph below depicts a proportional relationship, and then we need to justify our answer. So let's go ahead and take a look at graph A. As we look at the taxi fare representation here, we can see that the points are aligning into a straight line. But the problem is that we have this one point up here on the y-axis that does not go through the origin. It looks like it's off of it a little bit. So it does satisfy the fact that it goes through the line, but it does not go through the origin. Therefore, no, this thing is not a proportional relationship. We only had one of the two requirements. If we look at B, yes, the points create a straight line. Also, that point does fall on the origin now. So we do beat both criteria. Therefore, yes, it is. And lastly, if we look at C, this is the graph of the area of a square as it relates to its side length. So as our side length increases, that's the area that we're coming up with. And notice it does go through the origin, so we satisfy the first one, but then it doesn't form a straight line. This thing is curved. Therefore, no, it is not. You've seen examples like these before. Now for example number 4, now what we're looking at is equations. So we looked at charts, we looked at graphs, now we're looking at equations, and hopefully we're getting to the point where if we just look at the equation, we know whether or not this thing is proportional. So let's start with C. We have the circumference is equal to pi times diameter. So circumference is equal to pi times diameter. Well, when it comes to the equations, we got to have two variables or two unknowns, which we have. And then we also have to have this constant amount, okay? A value that's never going to change. And notice with our pi amount here, regardless of what our diameter is, the pi is never going to change. It's always going to be 3.14. Okay, so this one here, it does satisfy to be a proportional relationship. If you recall with a direct variation, it looks something like this. We had some y is equal to a constant k times x. One of our examples was the number of minutes is equal to 60 times the number of seconds that we have. Okay? Because there were 60 seconds in a minute. If we move on to part B, area is equal to pi times radius squared. If we look at this formula, A is equal to pi times radius squared. Now it's very similar. We have our two variables. We also have that constant, but now we have this exponent of 2. And as soon as your exponent changes, now it is no longer a proportion. And lastly, if we look at C, y is equal to 2x plus 1. Okay, again, y is equal to 2x plus 1. Here's my two variables. Here's my constant rate of change. But if we go back to the idea of slope-intercept form, we recognize that our y-intercept here is no longer 0, but instead it's 1. So if we go back to our previous example, here's 1 on the y-axis. We know that this equation of this line is going to go through 1. And while it creates a straight line, it doesn't go through the origin. So here's your hint. As soon as you see this +1 or -7 or +10, whatever it may be, if it's not 0, then it is no longer a proportional relationship. So, a couple of them that I want you to take a look at. I want you to do B, D, E, and F.